Imagine you're given two envelopes. One has double the money of the other. You pick one, but before you open it, you get a choice: stick or switch. What should you do? A simple calculation suggests that switching increases your expected return by 25%. But wait, that doesn't make sense. If switching is always better, shouldn't we keep switching forever? This is the famous two envelopes paradox. Let's break it down and see where the mistake lies. First, we name the two envelopes A and B. Say you choose envelope A initially. Let's denote the money in envelope A as X. This means that the other envelope, B, will either have twice the amount, which is 2x, or half the amount, which is 0.5x. Both possibilities are equally likely, each with a 50% probability. We can now calculate the expected amount of money in B. The expected money is half the time 2x and the other half 0.5x, which gives us 1.25x. So voila, we have a 25% increase in expected return if we switch rather than stick with our initial choice. But wait, this is strange. What if we had initially chosen B instead? By the same logic, we would again find that switching to A increases our expected return by 25%. But both envelopes can't be better than each other at the same time. That's the paradox. The apparent contradiction arises because we are not applying probability logic properly. You see, the total amount of money in the two envelopes is fixed. Let's denote this total money as 3x. Now consider the two possible cases. In case 1, envelope A contains 2x and envelope B contains x. If we initially choose A and then switch to B, we lose x. So the gain on switching in this case is negative x. In case 2, envelope A contains x and envelope B contains 2x. This time switching is profitable because B has twice the money. We gain x on switching. Now let's take both cases together. In case 1, where A has 2x, we lose x by switching. In case 2, where A has x, we gain x by switching. Since each case happens 50% of the time, the total expected gain from switching is half the time negative x and half the time positive x, which gives us 0, which means switching doesn't actually give us any advantage. The two envelopes paradox tricks us by making us think the expectation calculation works the same way no matter what. This paradox teaches us an important lesson. When dealing with probability, we have to carefully consider how values are assigned and whether our assumptions make sense. Probability paradoxes like this one show us how easy it is to be misled by seemingly logical calculations. The two envelopes paradox may not have a real-world impact, but the way we think about probability and decision-making does. Thank you for watching. If you enjoyed this breakdown, make sure to like, subscribe, and share your thoughts in the comments. Would you have switched or stayed? Let's discuss. Stay tuned to Mentis Moto. Until next time.